Okay, let's finish or follow up some more with the law of sines. Just want to remind you that there are three ways to use the law of sines. One is to use it with A's and B's. Another is to use it with A's and C's. And another is to use it with B's and C's. The bottom line is if you have 3 out of 4 pieces of information in any one of these statements, so of the A's and the B's, let's say you were given this angle, and this side, then you could find that side. Or say you were given this side, and this angle, then you could find that angle. Or say you're given this angle, and this side, you could find that side. So let's go on to, we've done this question already. Let's go ahead and go on to this one right here. So what I'm going to highly recommend is that you fill in this box because there's 6 pieces of information for any given triangle. There's 3 angles and there's 3 sides. So fill this in, and if you discover that you have 3 out of 4 pieces of information, so 3 out of this being the last, 3 out of 4 pieces of information, or prior to now I've said if you could cover up this row and see that you have 1, 2, 3 out of 4, then you could, and I'm going to unhighlight all of this now. I'm going to use the form of the law of sines that uses A and C's right now because I want to find side C. So side A, I'm going to put in 12.5. Angle A, I'm going to put in the 76.1 degrees with the word sine. Angle C, I'm going to put in 41.8 degrees. And then if you would remember that the shortcut is to multiply these two together, so you'll take 12.5 times the sine of 41.8, and then you'll divide it by what's opposite your unknown. So I'm going to divide that by the sine of 76.1 degrees, and that will give me the value for side C. Let's do that real quickly. I'm going to scale this calculator down a little bit. So 12.5 times the sine of 41.8, and I like to hit enter here. You don't need to. And then divide by the sine of 76.1. If you didn't hit enter, you have to at least close your parentheses. So side C in this problem is, let's see, my sides are 3 significant digits to the tenths place. 12.5 was given. I guess I'm going to call this 8.58. So side C is 8.58. I forgot to do the easy first step, which is to find angle B, and I do that by taking 180 degrees and subtracting the sum of the other 2 angles, the 76.1 and the 41.8. And I have done that already, and I believe that would be 62.1 degrees. Now maybe I did that on purpose so that you could see that I wanted to use the A's and C's initially. In case I make a mistake in doing this subtraction, I was avoiding using that B yet. But now I've got to find side B. So I'm going to use the A's and the B's to do that because I calculated C, and it was quite a bit of calculation to do that. So if I had an arm to put over top of this right now, I'd cover this up so that you could write the law of sines by writing A over the sine of A equals B over the sine of B. This time, I'm going to, oops, I just took that value away. This time, I'm going to do this by going right into the formula. So I'm going to put the A value of 12.5, divide it by the sine of 76.1 degrees, and set that equal to side B over the sine of 62.1 degrees. And then again, you got to take this product right here, 12.5, times the sine of 62.1 degrees. And then you've got to divide it by the sine of 76.1 degrees. This is just algebra. I'm just setting the cross products equal. It lets me solve for b. And if you type this into your calculator, you should get side b is 11.4. So again, I calculated this. Remember, and I'm going to keep doing this just a little bit, it's true always. I'm going to go ahead and take my calculator, and I'm going to check side a over the sine of a. So let's take a look at side a. I'm going to move this up. Divided by the sine of angle a. And see if that equals side b divided by the sine of angle b. Good enough. And see if that equals side c, which was 8.58, divided by the sine of 41.8. And see if that's close to 12.87, 12.88, 12.89. Please, it's not going to be the same, but if those ratios are the same, then we know we did this problem correctly. All right, so that was a case 1 problem where you're given 2 angles and a side. Now we're going to take a look fairly quickly at 2 sides and the angle opposite one of them. It's still a law of sines problem, so not to fear. So I'm going to fill in this box. And at this point, I'm not even all that concerned about drawing a picture of this, but I will at some point. So these are all my given values, and I'm going to go ahead and put a check mark by my givens just so I remember. Okay, so you must remember that this is not a right triangle, so don't be trying to use the Pythagorean theorem on this just because you have side A and side C. It is not a right triangle. So what you've got to look for is you've got to look for those 2 rows where you know 3 out of 4 pieces of information, basically, because law of sines is easier than law of cosines. So I'm always looking to use law of sines. Always, always. Now, case 3, this is case 2 right here that we're doing right now. Case 3 and case 4, I'm not allowed to start with the law of sines, and you'll see why in a bit. But this case 2 problem, where I have 2 sides and the angle opposite one of them, I'm going to set side A over the sine of angle A, which I do not know, equal to side C over the sine of angle C. I'm going to show you the algebra again this time. Set this cross product, 150.4 times the sine of 76.43 degrees, and set that equal to this cross product right here, which is 250.9 times the sine of angle A. And to get the sine of angle A alone, now I'm going to divide both sides by 250.9. So, truthfully, in an effort to get this angle A, I still take this product and divide by what's opposite my unknown. So I'm going to take my calculator, and I'm going to take 150.4 times the sine of 76.43. I'm going to close my parentheses. I can hit enter, or I could just go ahead and hit divide by 250.9. And that number is going to be a ratio for the sine of angle A, 0.5827 I'm going to write down. And that's equal to the sine of angle A. Remember, to find the ratio for angle A, you'd go into the calculator and you'd say, hey calculator, if the ratio is this, would you tell me the size of the angle? And that's how you state that. So we're going to go second sine, second answer. So please notice that I'm using the 0.5827079781 to find the size of angle A, and I find out that it's 35.64 degrees. So angle A is equal to 35.64 degrees. And I'm going to fill that in right here. You know, I meant to unhighlight this, but it's too late now. So once I've used law of sines, and I had 2 sides given, and an angle opposite one of them, so it would have had to been angle C or angle A if it was case 2, where it's two sides and the angle opposite one of those sides. Then I can go ahead and find angle B by taking 180 and subtracting angle A plus angle C, or subtracting both of those angles. Let's see, so for this one, it's 67.93. And now I'm back to law of sines to find side B. I'm going to choose to use the B's and the C's this time because the C's were given. Now mind you, I calculated angle B, which was calculated from angle A, so any errors are going to carry through. But I'm going to go ahead and set this up as B over the sine of angle B equals side C over the sine of angle C. Boy, you have to have that word sine with the angle. To solve for B, we're going to multiply these two together. So 250.9 times the sine of 67.93 degrees. Then we're going to divide by what's opposite the unknown. So we'll divide by the sine of 76.43 degrees. And when we do that, we'll have a value for side B, which I have of 365.1. I'm going to go ahead and fill this in right here. I have already checked this. I've already taken this divided by the sine of this, and this divided by the sine of this, and this divided by the sine of this, and they all work out perfectly. So this is the introduction to case 2. We'll go ahead in our next segment, follow up with this problem. So if you would try this one on your own and then check the video, that would be awesome.